So, what is a Docker image, really? It's a term you hear all the time in software, and it's absolutely fundamental. In the next few minutes, we're going to pull back the curtain and break down exactly what it is, how it works, and why it's such a game changer. And we have to start with this phrase. Come on, you've heard it, right? It's probably the most infamous line in all of tech. It's that moment of pure frustration when everything that worked perfectly on a developer's laptop suddenly just breaks somewhere else. And look, this isn't just a funny meme developers pass around. It's a very real, very costly problem that's been around for ages. An application that seems perfect in development can just fall apart the second you try to move it to a testing server, or, even worse, into production. The root of the problem is that no two computers are ever truly the same. I mean, your machine might have a slightly different version of a key library. The operating systems could have tiny variations. Configurations can drift over time. And any one of these little inconsistencies can create this minefield where your code just blows up when you least expect it. So what's the fix? How do we escape this cycle? Well, the big idea is to stop shipping just the code. Instead, what if we could package up and ship the code inside its entire environment? And that solution is the Docker image. The best analogy? Think of it like a standardized shipping container, one of those big metal boxes. It doesn't matter if it's on a truck, a train, or a ship, what's inside stays protected and consistent. A Docker image does that for software. It's one single self-contained package with the app, the libraries, the tools, the whole shebang. So here's the official definition. A Docker image is a read-only template. Now, read-only is the magic word here. It means the image is a fixed, unchangeable blueprint. From this one master blueprint, you can spin up thousands of identical running copies of your application. We call those running copies containers, and they always start from the exact same perfect state. Okay, so what's actually inside this blueprint? What's the secret sauce that makes it all work? To get that, we need to pop the hood and look at the anatomy of an image. All right, check this out. The real genius behind a Docker image is its structure. It's not one giant clunky file. It's actually a stack of super lightweight individual layers. Let's start from the bottom and see how it's built. Way down at the bottom, you have the boot file system. Then you lay a base image on top of that, maybe a minimal version of Ubuntu. Now here's the cool part. Every change you make, like installing a web server or copying in your code, adds another thin read-only layer to the stack. And then finally, when you actually run the image, Docker slaps one last writable layer right on top. That's where your app actually lives and breathes. This whole layered system is incredibly efficient because of a pattern called copy on write. Basically, if your running container needs to change a file that's in one of those lower read-only layers, it doesn't touch the original. Nope. Instead, it just copies that file up into the top writable layer and makes the change there. The original layers stay pristine, which makes everything really fast, light, and reusable. Okay, so we get what an image is and how it's structured, but how do you actually make one? How do you define all those layers? Well, that's where the Docker file comes in. It's the recipe for building your image. Now, you could do this manually. You could start a container, make some changes, and then use a command like docker commit to save it. But that's kind of like quick saving in a video game. It's messy, and it's hard to remember what you did. The professional way, the repeatable way, is to write a Docker file. It's basically a simple script that automates the whole build process for you. And this is what a simple one looks like. It's just a plain text file with a few instructions. Don't worry about memorizing every command right now. Just notice how clean and readable it is. It's a step-by-step recipe that anyone on your team can understand. Let's break it down real quick. From just says what base image we're starting with. Label adds some useful info. Run tells Docker to execute a command, like installing some software. And expose is like a little note saying which network port the application inside will be using. And guess what? Each one of these instructions creates a new layer in our image. This quote from The Docker Book by James Turnbull just nails it. Each instruction adds a new layer to the image and then commits the image. The recipe, line by line, builds the exact layered structure we were just looking at. It's elegant. Building your own perfect self-contained image is amazing, but the real power of Docker kicks in when you start sharing it with your team, with your company, or even with the whole world. And the system for sharing is pretty simple. Your images are stored in what are called repositories. Think of it like a GitHub repo, but for images. And those repositories live on a registry.
The biggest, most popular public registry out there is Docker Hub.
And here it is. Docker Hub is basically a massive public library where you can find pre-built, ready-to-go images for just about anything you can think of. Databases, programming languages, you name it. It's also where you can push your own images to share with others. Now, on Docker Hub, you'll generally find two types of repositories. First, you've got the official, top-level ones. These are curated, secure, and maintained by vendors or Docker itself. These are the ones you can trust. Then you have user repositories, which is this incredible, vast collection of images contributed by the community for every possible niche. So let's bring it all home. A Docker image is a layered, portable, and reproducible blueprint for an application, built from a simple recipe. It's the technology that finally, truly solves that old works on my machine problem. And that leaves us with one final big question to chew on. If any application can be perfectly packaged and run anywhere, on any machine, with total consistency, what does that really make possible?